Geometry Topic 7, Quadrilaterals. In a parallelogram, we will find that opposite sides are parallel. Parallel is going to be shown by matching arrows. So where I have one arrow, it is parallel to the other side that has one arrow. In a parallelogram, we will also find that opposite sides are equal. We will show that sides are equal when they have the same number of lines next to them. So a side that has one line through it will be equal to the side that has one line through it. The side that is marked with two lines will be parallel to the other side marked with two lines. In a parallelogram, we will find that opposite angles are equal. That means any two angles that do not share a side will be equal to each other. And I see that I have one more pair of opposite angles that will be equal to each other. If two angles do share a side, that is, if they are adjacent angles, we will find that they add to 180 degrees. So the blue angle and the green angle would add to 180 degrees. And the diagonals bisect each other. A diagonal is a straight line from one vertex of the shape to the opposite vertex. So here is one diagonal, and we have the other diagonal. And they bisect each other. So 1/2 will equal the other half. And this is true for the other diagonal as well. 1/2 will equal the other half. Rectangles. In a rectangle, you will find that the opposite sides are congruent, same as in a parallelogram. So, same as before, we'll mark things as congruent with one or two lines. In a rectangle, each interior angle is 90 degrees. So at every vertex, we're going to draw a square, which means 90 degrees. A rectangle is unique because its diagonals are congruent and bisected. What that means is when we draw our diagonals, we're going to find that every single half is exactly the same. This piece equals this piece equals this piece equals this piece. They will all have the same value. Something interesting that happens because all of these pieces are the same is that two different isosceles triangles are formed. So we're going to find that when we draw our diagonals, these two angles are going to be congruent, and because the sides of a rectangle are parallel, the alternate interior angles to these would be congruent as well. The same is going to go for the other two pairs. In a rhombus, all the sides are equal. We'll denote this with one line at every side. The opposite angles are equal, same as in a parallelogram. So if sides do not, if an angle does not share a side, then they will be equal. So this angle is equal to its opposite. Adjacent angles still sum to 180 degrees, same as the parallelogram. So the purple angle plus the green angle will equal 180 degrees. The diagonals are perpendicular. This is unique to a rhombus. That means that when we draw in our diagonals, they are going to hit each other at 90 degrees. And the angles are bisected by the diagonals. So when I drew that diagonal line, it's going to bisect each angle. That is, this half is equal to this half. Same for the opposite angles because my opposite angles are equal. These two segments would be equal to each other, and these two halves would be equal to each other as well. Notice that these diagonals and the side form a right triangle. Right here is our right triangle. We could use that with our Pythagorean theorem to solve. A square. We're going to find in a square that all the sides are equal, same as a rhombus. We're going to find that all the angles equal 90 degrees, just like a rectangle. And we're going to find the diagonals are perpendicular, equal, and bisect angles and each other. Whew, that's a lot going on. So here's what that is going to look like. Every angle at the center of a square will be 90 degrees. All of these little diagonal halves will be equal to each other. And, really interestingly, each of these 90-degree angles gets bisected, which means that every little half angle in a square is 45 degrees. Every single half angle is 45 degrees. Notice that the diagonals inside form a 45, 45, 90 right triangle, which we can definitely use to solve. In a trapezoid, one pair of opposite sides are parallel. These are called the bases. Each side has supplementary angles. In an isosceles trapezoid, again, one pair of opposite sides are parallel, but now we're going to find that the other pair of opposite sides are equal. That'll be these right here. And remember, when things are equal, we're going to mark them with straight lines. Unique to an isosceles trapezoid, we're going to find that the base angles are equal. Remember that the bases are the parallel sides. So this angle at the top base would be equal to the other angle that touches the top base. Same for the bottom base. This angle that touches the bottom base will be equal to the other angle that touches. Same for a normal trapezoid. Each side has supplementary angles, which means that if I take purple plus green, it will equal 180 degrees. Lastly, we're going to find that in an isosceles trapezoid, the diagonals are congruent. So, from one vertex to the other will be equal to the other vertex, to the last one. Both of these segments are congruent. Lastly, we have our kite, my favorite shape. In a kite, we have two pairs of consecutive sides that are equal. All right? So up here towards the top of our kite, we'll mark with one line and its matching equal side. And towards the bottom of our kite, marking with two lines, we'll find that this side is congruent to this one. Where the two different sides touch, we're going to find opposite angles that are equal to each other. So this angle will be equal to the other angle. I think of it as the wings. The wings of the kite are symmetrical. They're equal to each other. And in a kite, just like a rhombus, the diagonals are perpendicular. That is, when I draw in my diagonals, I'm going to find that they hit at 90 degrees. Interesting enough, I make another right triangle here. And in fact, the diagonals on the side form two different right triangles. This one here on the right, and this other triangle over here on the left. Now, let's try some solving. When you start the problem, we're going to look to see which of the shapes you'll be solving with to know its properties. Then, you'll see if you're solving for a side or an angle. Problem 1. Parallelogram ABCD is a rhombus with the measure of angle EBC equal to 36 degrees. What is the measure of angle DAE? Here's our options. We observe two things. One, the shape is a rhombus, and we see that we're solving for an angle. So we're going to use our angle rules. angle D to A to E will be right here, and that's what we want. We'll label it X. Because this is a rhombus, opposite angles are equal, adjacent angles add to 180 degrees, diagonals are perpendicular, and angles are bisected. All of the rules that we've learned from before. Because angles are bisected, we're going to find that if D to A to E equals X, then E to A to B is also X. And if E to B to C is 36 degrees, then angle ABE will also be 36 degrees. Now, let's use the fact that our diagonals are perpendicular. That is, our diagonals hit each other at 90 degrees. Now I see I have a nice triangle here with all of its angles labeled. The diagonals inside form a right triangle. And the three angles in a triangle always add to 180 degrees. So I can take X plus 36 degrees plus 90 degrees, that perpendicular angle, and it will equal 180 degrees. Combining like terms, I find that X plus 126 degrees will equal 180 degrees. Subtracting 126 degrees from both sides, I find that my X will be 54 degrees. Ooh, man. The diagonals of rectangle KLMN intersect at the point 2, 1. One of the vertices of the rectangle KLMN is located at -4, 5. Which of the following could be the location of another vertex of this rectangle? To make graphing problems easy, the first step is always to plot the points. So I'm going to plot the intersection at the point 2, 1. This is where your diagonals intersect. And I'm going to plot one of the vertices at -4, 5. -4, 5 will be another vertex. Which of the following could be the location of another vertex of this rectangle? Remember, any quadrilateral has 4 vertices, or corners. Now, let's plot our possible solutions. 8, -3 is right over here. 3, -1, right 3, down 1. -2, 3 will be left 2, up 3. And -10, 9 will be left 10 and up 9. Because the shape is a rectangle and we're using the diagonals, we're going to use the rule that diagonals are congruent and bisected. We need to pick a solution that is the same distance from where the diagonals intersect as the given vertex is. We're trying to find a segment that is the same length as this one. With the graph, the easiest thing we can do is use the compass, where the intersection of the diagonals will be the center of our compass, where we put the sharp end, and the vertex is where we're going to put our pencil end, our writing end. When you use the computer, your compass is going to look just like this, where the black circle is the center, and the point of the arrow is going to be where your pencil goes. Drawing our circle, we can see that the dot 8, -3 is on the circle. That is, it's going to be the same distance from where the diagonals intersect as the other vertex. Therefore, our solution is going to be 8, -3. Note, I didn't have to use the compass. I could have used the distance formula or the Pythagorean theorem to see which segment has the same length. In rhombus ABCD, AC equals 30 inches and BD equals 40 inches. What is the perimeter of the rhombus? We observe two things. This shape is a rhombus, and we are solving for the perimeter. Note, the perimeter is the sum of all the sides of a shape. In a quadrilateral, that will be all 4 sides added together. Because we're dealing with the sides of a rhombus, we'll write down our rhombus rules. All sides are equal and diagonals are perpendicular. From A to C, I see that it equals 30 inches. That's given to me. And they also give me that from B to D is 40 inches. That's not quite enough to solve yet, so let's go all the way back to our parallelogram rules. Because a rhombus is a parallelogram, the diagonals bisect each other. So if diagonal AC equals 30 inches, then the segment CE will be half of that. So I'm going to take 30 inches, divide it into 2 pieces, and I find that segment C to E is 15 inches. Similarly, if diagonal B to D is 40 inches, then the segment B to E will be 40 divided by 2, or 20 inches. Because the diagonals are perpendicular, the diagonal halves become the legs of a right triangle. We'll draw in our 90-degree angle, and if we have 2 legs of a right triangle, I know I can use the Pythagorean theorem to solve for the 3rd leg. Remember that the legs will be our A and B, while the hypotenuse of the right triangle, that is the side across from the 90-degree angle, must always be my C. So in a right triangle, my A squared plus B squared equals C squared. That is, 15 squared plus 20 squared will equal C squared. Evaluating, I find that 15 squared is 225, plus 20 squared, which is 400, equals my C squared. Combining like terms, that means that 625 is equal to C squared. The opposite of a square will be a square root, so when I square root both sides, I find that my C will be 25. Finally, a rhombus has all equal sides, so the perimeter is 25 plus 25 plus 25 plus 25, which equals 200 inches.